Hello everybody, it's Mr. Nelson here. I am going to talk through the beginning of Module 2, and Module 2 is quadratic functions. And Topic 1 of Module 2 is going to be graph features of quadratic functions. Now the majority of this module is review from Algebra 1, it just goes a little bit further in depth. And to begin, I'm going to go through Objective 1, which is just an introduction to graphs of quadratic functions. And we're going to take a little bit of notes to hopefully spark the memory of what some key features of graphs of quadratic functions are. So, a quadratic function can be written in the form ax squared plus bx plus c. Now, it is very important to note this is standard form. Please keep that in mind. Standard form because the powers are descending. It's the highest power to the lowest power and finally ending with the constant number c. Now, a, b, and c are all real numbers, and I'm not going to fill that one in, but they're considered a and b are coefficients and c is a constant number. Now the graph of a quadratic function is called a parabola. Hopefully that word looks familiar. And this is where everything that I'm about to talk about now, you're going to have to be able to look at a graph of a function and tell me what's happening based off the graph itself. And it begins now. So when a is, so the leading coefficient right here, when a is positive, the parabola opens up. I'm going to put in parentheses smiley face, just to help you remember that. Smiley, it makes a smiley. Positive people are happy, it makes smiley faces, alright? And it has, and this is important too, you have to remember that positive and minimum go together. So it has, when a is positive, it makes a smiley face, means it opens up, and it has a minimum value. And that is displayed right here, this graph. If you notice, there is the minimum value. You'll hear me say mountaintops and valleys. That is a valley. It meets at a low point, as do valleys. All right, moving on. When a is negative then, I'm going to put frowny. When a is negative or frowny, parabola opens down, makes a frowny face. Negative people tend to be unhappy or sad, and sad people frown. So it's a good way to remember that. And same thing, negative has a maximum value. So you need to be able to remember that too. Opens down, and this is the graph of, or an example of this, but has a maximum value or a mountaintop right there. Two things you have to keep in mind already. Now, moving on, the most important point of a parabola is called its vertex, right here. The vertex. You need to know what the vertex is. The vertex is either the highest maximum or lowest minimum point of a parabola. So you also need to know that a vertex is either the maximum or the minimum. So what I shaded in purple up here, this is a minimum value, but it's also the vertex. This is a maximum value, but it's also the vertex. The vertex can either be a minimum or a maximum, depending on the leading coefficient a, whether it's positive or negative. All right? Moving along, the vertex is on the axis of symmetry, meaning axis of symmetry is a vertical line they put line, I don't need to write line, is a vertical line that splits the parabola into two equal halves. So what that means then, let's say, and it is true, this example over here in the blue, this blue parabola, it's negative because it's opening down. The vertex is right here. I'll do a different color. The vertex is right here. All right? The axis of symmetry is the x value of the vertex. So this vertex from a plotted point is over 2 up 1. So the x value is 2, the y value is 1. X and y. Now the axis of symmetry, again, is the equation x equals 2. You need to be able to say x equals something for the axis of symmetry. And if you notice, I'm going to draw a rough sketch. But at x equals 2, that is the axis of symmetry because it cuts it in half. That vertical line that I just drew cuts it in half. And so it's the same thing on the left side as it is on the right side. Parabolas are a beautiful picture because of that, because they are symmetrical. Meaning same on left and right. Now, a couple more pieces to this video, and then the next video we're going to work through actually figuring this out for our own right. But I'm going to talk about the y-intercept, x-intercept, domain, and range of a function. And then we'll be good. But the y-intercept is where the graph crosses, or the y-intercept of a parabola is where the graph crosses, goes hand in hand with the y-axis. Makes sense? So wherever it hits the y-axis is the y-intercept. It intercepts the axis. The y-intercept always has an x value of 0. Alright? So this gets a little bit confusing, but the y-intercept always has an x value of 0, and then the x-intercepts over here, I'll fill in, always have a y value of 0, so it's opposite. But I'll get to x values in just, or x-intercepts in just a minute. Now, for a parabola, the y-intercept will be the point 0, comma, whatever c is. Alright? So if I go back up to the equation, we're going to talk about this, how to find the y-intercept algebraically. But the input, remember from function work that we did in the prerequisites, the input I'm saying is 0 because the x value is 0 right here. So if I input 0 into a function, any given function, let's go up here and look, it would be whatever a is times 0 plus whatever b is times 0. So both those would go to 0, and then it would be plus or minus whatever c is. And so the y-intercept is very easy to find because the 0 cancels out the a and the b terms, and it leaves you with the c term, whatever that might be. So that's why algebraically it is always 0, comma, whatever that c term is. So let me give you a quick example. I do want you to get this. Let's say it's 3x squared minus 2x plus 4. The y-intercept of this given function, again, I'm going to input 0 in for my x's, because the y-intercept always has an x value of 0. That means then that this y-intercept, I'll write it right up here, is 0, comma, 4. Whatever that c value is what the y-intercept is. Alright? Now, graphically to find the y-intercept is really pretty straightforward as well. Now, it's where it hits the y-axis. So if I look at this blue parabola up here, I see that it hits the y-axis right there. It crosses over, it intercepts with the y-axis right there. If I plot that point, it's 0, comma, 0, comma, negative 3. Alright? So if you notice, again, the x value for any y-intercept is 0, and then the y value is wherever it crosses the y-axis, which in this case is at negative 3. So that's how you find the y-intercept. Now the x-intercepts are a little bit different. They follow the same lines, meaning the x-intercepts of a parabola are where the graph crosses the x-axis. Pretty straightforward. Now I already mentioned this, the x-intercept always has a y value of 0. Alright, so it's going to be some number, then comma 0, where this is the x and this is the y. Because again, if you notice on this graph up here, the x-intercepts are where they cross the y-axis. I'm sorry, the x-intercepts are where they cross the x-axis. So in this case, there's 2 of them. And there's a couple things I want to mention about x-intercepts, alright? They're called x-intercepts because they intersect with the x-axis, but they're also called, you need to write this down, they're called roots, solutions, and zeros. Alright, roots, solutions, and zeros and x-intercepts all mean the same thing. Right? They're all talking about where, if it's possible, where they intercept the x-axis of a parabola. But really, if I have a given, so let's say I'm going back to this one, if I have a given quadratic function, this power of 2 means that I will have 2 roots, solutions, or zeros, and if they happen to be real solutions, they will also be x-intercepts, meaning that the graph of them will cross the x-axis somewhere. All right? That's just a precursor to later in this module and then module 3 as well. But the x-intercepts are very important. We will solve quadratic functions in module 3, and that means we're going to be finding x-intercepts or roots or solutions or zeros. All the same thing. But again, if I go back to the graph here, this solution is 1, 0, and this solution is 3, 0. Now you notice, again, the y-intercept has an x value of 0, and the x-intercepts have y values of 0. So that is very important to know, so please make mental note of that. And now, to finish off this video, I'm going to talk about domain and range of a function. So the domain of a function is the x values, all right? And it's horizontal, and I'm going to put left to right. That's how you read domain, left to right, just like a book. And then finally, I think that's it. Domain of a function is the x values. It's the horizontal x-axis. Oh, that's what I forgot. X-axis. So it's the x values, the horizontal x-axis, and you read it left to right like a book. The range is the y values. It is vertical, and you read it from floor, always the basement first, to ceiling. I don't know if I spelled ceiling right. Floor to ceiling. Just think about, you touch the floor before you touch the ceiling. You always have to read it floor to ceiling. And then finally, it's the y-axis is what I care about. All right? So I'm going to do a brief intro. I'm going to show you further along how to find the domain in another video. But let's look at this blue graph here. So at this point, I'm going to erase all the stuff around it because I need to look at it a little bit more. So the domain is left to right, horizontal x-axis. So I'm going to read it like a book. The leftmost point. Now, this arrow goes down forever, but it also goes left forever. So the leftmost point is, and maybe you remember this, it's negative infinity. And then finally, the rightmost point, this arrow also goes down forever, but it goes right forever as well. So the rightmost point is positive infinity. The domain of a parabola, a quadratic function, will always be negative infinity to positive infinity. And another way to write this is this symbol right here, which means all real numbers. Meaning, all real numbers, if I plug in all real numbers for the x of the quadratic function, they will satisfy the function and they won't break the domain. Now, the range is a little bit trickier. The range, again, is read floor to ceiling. I'll do this in red. The floor, both of these arrows, the lowest most point of this function, they go down forever. All right? So they go down forever. So this starts at negative infinity, kind of like the domain. But now it's a little bit different. It does not go up forever. It stops right here. That is the ceiling point. Now, if you notice, the ceiling, this is our vertex from way back in the beginning of the video. This vertex is 2, 3. I care about the y values in the range. So the ceiling, the tallest point, it's not 2, 3. Silly. It is 2, 1. The tallest point in this vertex, the tallest point in this parabola, is the y value of the vertex, which is 1. Thank you for watching the intro to quadratic functions and their graphs.